This is another rational inequality. We have a fraction greater than or equal to a fraction plus 1. I use the word rational. In fact, 1 is an integer and also a rational number because 1 can be written as 1 over 1. Okay, back to this business. What's the first step? The first step, just like the nonlinear inequality, we want to move all the terms to the left-hand side. So let's do that. We have x divided by x plus 2 minus 1 divided by x minus 1, and then we subtract 1. We have everything greater than or equal to 0. Let's get a common denominator, and then I will claim the left-hand side to be my function. So for the common denominator, I will use x times 2, x minus 1. So x plus 2. Did I say x times 2? X plus 2, x minus 1. So this is x times x minus 1 minus 1 times x plus 2. So for negative 1, then you will have to subtract the product x plus 2 and then x minus 1. You have the whole thing greater than or equal to 0. Wow, this thing we have to take a look at what that equals to. Okay, we have x squared minus x, right? We have x squared minus x, and then we have minus x minus 2 minus x minus 2, and then we have to subtract the product of these two factors. Okay, let's do that. This is a x squared minus x plus 2x minus 2, and then can we do one more step further? Should I squeeze that over here, or I should move that over to the other side? I will just do it right here. Okay, so we have x squared minus 2x minus 2, and then minus x squared. This is a negative 1 plus 2, which is a positive x, but you have a minus in front of that, minus x, and then plus 2. So the 2's got cancelled, right? So these 2 and these 2 got cancelled. And what else? The x squared got cancelled as well. So we have a negative 2x subtract x. Then we have a negative x. We have a negative 3x. Did I say negative x? Negative 3x divided by, what else? Negative 3x divided by the common denominator, x plus 2, and then times x minus 1 greater than or equal to 0. And then I am going to claim this as my fraction. Sorry, as my function. I'm going to claim this as my f of x. I missed a 1 in here, right? X minus 1. I did not miss the 1 that makes this look like a plus. Minus 1. And then I claim this to be my function. Now, for rational inequality, most of the time, you will get a rational function as the fraction. Now, when you set that equals to 0, you might say, okay, we multiply the denominator on both sides, and we only have negative x equals to 0. That is right, but for rational inequality, you have to take care of the numerator and denominator. So when you let that equals to 0, you have to take care negative 3x equals to 0, x plus 2 equals to 0, and then x minus 1 equals to 0. So the key numbers are x equals to 0, x equals to negative 2, and x equals to 1. They are my key numbers. Key numbers. And then you put the key numbers on the number line to construct your test intervals. You have a negative 2, you have a 0, you have a 1, one line, 3 numbers. You cut this line into 4 pieces. Negative infinity to negative 2, negative 2 to 0, from 0 to 1, from 1 to positive infinity. You have your negative infinity to negative 2, and then you have your negative 2 to 0, and then you have your 0 to 1, and then you have 1 to positive infinity. And then the test value, so let's match the color that I used to set up this problem. I think this is the right color. X equals to negative 3, just pick a value within the interval. X equals to negative 1. X equals to, this one you have to pick 0.5. And then this one I will just pick x equals to 2. And then I claim this to be my fraction. The next step is you plug in each test value to the function to see which one is greater than or equal to 0. Or you plug in each test value to the original inequality to see which one is satisfied. And then you pick the one that is satisfied. Right? Just two different ways to do it. So we have f of negative 3. So f of negative 3, that is a negative 3 times negative 3 divided by negative 3 plus 2 multiply negative 3 minus 1. What is that? That is 9 divided by 4, right? 9 divided by 4. And then this is a positive. Are we looking for positive? Yep. This is greater than or equal to 0. And then f of negative 1, you have negative 3 times negative 1 divided by negative 1 plus 2. And then negative 1 minus 1. That one I have 3 over negative 2. This is less than 0. We do not consider that. And then f of 0.5 equals to negative 3 times 0.5. And then denominator 0.5 plus 2. 0.5 minus 1. That one gives you negative 1.5 divided by negative 1.25. I don't need to know what that equals to. All I need is that is greater than or equal to 0. And then the last one, f of 2, you have negative 3 times 2 divided by 2 plus 2. Also 2 minus 1. This is a negative 6. The bottom is a positive 4. This is less than 0. We don't need that because, as always, look at this. We are looking for greater than or equal to 0. The greater than or equal to sign is from right over here. Greater than or equal to 0. And then now we have our interval. We are looking for the first interval and the third interval. So they are my solution sets. And then I draw a conclusion. I say solution sets. And then draw the number line again. We have negative 2. And then from 0 to 1. From 0 to 1. Do we have an equal? Yep, we have a greater than or equal to. Take a look at the very beginning. We have greater than or equal to 0. So when you draw the arrow, I have to include, this is a negative 2, right? This is a negative 2. You have to include your negative 2. And then what else? Between 0 and 1. Okay, so between 0 and then between 1. And then we do this. So this is from negative infinity to negative 2. And then, from negative 2, square bracket, and then union, square bracket, from 0 to 1, and then the inequality is x less than or equal to negative 2, 0 less than or equal to x less than or equal to 1. If there is no equal, then this is an open circle, open circle, open circle. They are all parentheses, and there is no equal in the inequality. What is the union mean? Let me make this look like a square bracket for you. So square bracket. The union means every time you select an x values, the x value is either in this interval or in this interval. That's why they use the word union. Union means or. You can use the word or you can just draw a comma. And then one other question that you might want to ask me is, hey, back to your test interval, you did not use a square bracket. That it is okay. You don't have to use square bracket in the test interval. You can just imagine that there is no equal. But at the end, when you present your solution set, you always have to go back to the problem, make sure there is an equal, and then you use solid circles. All right, that is the end of this video. If you like the way I teach rational inequality, give me a thumbs up, a subscribe. I will meet you all in the next lesson. Signing out.